Hey everybody, welcome back to some more live coding. Today we're going to do some Rust. Now, I looked at Rust the other day and I had one stream called Learning Rust from Scratch, and that was my first look at Rust ever. And I added some code to the cookbook that I have up here, and so we added a few examples like taking command line arguments, doing file operations, doing an HTTP request, packet capturing, TCP client and server. I forgot we did some of those. So that was pretty good for the first day of learning how to do Rust. So today what I'm going to do is take it a little further and just keep building onto these examples and see how much Rust we can learn today. Maybe look up some cool packages and see what's out there. See what Rust can do. Now, I don't know of a good IDE for Rust, so I've just been kind of defaulting to Visual Studio Code as a simple editor. But maybe I can do a quick search. Does anybody have any suggestions? Oh, wait. I thought for a second JetBrains had a Rust tutorial, a Rust app, but it's just a plugin for IDEA. So I'm gonna try that out because I really do like the JetBrains suite of tools. And if you didn't know, they're actually open source. The core is actually open source. And it's very extendable, but yeah, it's on GitHub here. So you can actually build it and run it all for free. It is a community edition, so it is lacking a couple of the more advanced features, but the core is all there, which is really amazing. Okay, so let's try out Intellij and see if... Oh, so I still have my last project open, which was... The last Java project I worked on was our Minecraft Discord notifier. It's basically a two-way chat system to hook up a Minecraft server with a Discord server, so the chats go back and forth. But I'm going to close that. And I want to open that Rust cookbook folder I have. So let's open cookbook, and I'm going to open the Rust specific folder in there. Okay, now what I wanted to do was add the plugins, so I'm going to go check the settings and go to plugins, and I'm going to search for Rust. Okay, last updated February 14th, 2019, 12 days ago, over 500,000 downloads. Nice, I'm going to click it. Now there's not much description here, but I'm going to trust it. Oh, this isn't it is an official JetBrains plugin. Look, vendor JetBrains. Awesome, I did not realize they officially supported it. They have let's restart. Okay, so we're gonna use the Intellij as the Rust IDE. Okay. Alright, so what do we have already? Let's go to the README. Okay. Okay, look, we still have some topics from last time that we didn't cover, so this will be good. We'll just kind of work on some of these. So we started with Hello World. We covered adding dependencies. And how did we do that? I think you use... Oh yeah, you use this toml file. So you use the toml file, which is kind of like an INI file. Okay, plugin supporting toml. Yeah, go ahead and install it. go ahead. It'll probably give me some syntax highlighting. Yeah, go ahead and restart. Okay, so now we've got some nice syntax highlighting for the TOML file, and we have an IDE that will understand Rust. So we're up to a better start now. And by the way, if this font is still not large enough, just give me a chat in the YouTube chat and let me know. So we've got, so add a dependency, we add it in the metadata file, and then we also call extern crate at the top. And then if we need to like import something specific, we call the use. No cargo projects found. I'm not going to attach one to this one, but okay. I'm going to fix up this readme too. I noticed there were a couple tiny little markup problems I had before. I'm using restructured text, so now that looks a little better. So, same thing with the topics. I'm going to push these. And unfinished topics. And up here we'll say completed topics. Okay, and down here I'll do... Oh, what? I thought alt was the multi-cursor. Maybe not. We'll just do it like this. There's not that many. So we wanted to do what? Packaging and publishing a module, creating a CSV, making database connections. So we did hello world, adding dependencies, getting user input, taking command line arguments, reading and writing files, TCP client, making HTTP requests. See, I don't remember. I'm gonna have to look at that one real quick. Oh, that's right. We use this third-party module called request. And then you just call request.get. That was actually pretty nice to work with. It was pretty straightforward. Oh, so cross-compiling is one thing I was interested in. Cross-compiling. In Go, it's really easy to cross-compile. You just change your environment variable and tell it what architecture you want and what operating system. So you can cross-compile for Windows on Linux by just saying go OS equals Win32 and then compile, and then bam, you've got a .exe instead. So that's really cool, which is really nice also if you're on Windows and you want to compile something for Linux and push it to a Pi or a remote server or something. So let's see, cross-compiling Rust. Everything you need to know about cross-compiling. Okay, how easy is it? Here are the commands necessary to set up a stable Rust toolchain as a cross-compiler for ARM7. Yeah, so that's like a Pi or other small devices. Apt install GCC ARM. Rust up target add. Okay, so Rust up is the tool we used to add, to do the install and everything of the language and manage the language. And it has the docs feature. So I think we can do Rust up docs. Yeah, Rust up docs, and it pulls up the local documentation, which is really cool, especially if you're on a plane or in the woods or something. So you have to install a target, and then you just give it a flag of target. Tac target equals ARM7. And that's it. Wow, okay, so this is where all the magic happens. rust up target add. Now, I'm curious, are those officially supported targets? And what other targets do they support? Cross-compiling with Rust C. This is the easy part. Cross-compiling with Rust C, which is the default Rust compiler, requires passing a few extra flags. Dash dash target equals, and the linker. Okay. You can also use cargo, which is the package management tool. Now how does that work? Cargo new dash dash bin. And then, okay, so you set the targets in your metadata file, and you can set up probably multiple targets, I guess. Okay, are these the different targets then? Right now, you can only cross-compile the standard crates if your target is supported by the Rust build system, RBS. You can find a list of all the supported targets in the make/config directory. Note, linked directory is not the latest version. Okay, as of Rust C 1.0, 1.8.0, I see the following supported targets. Okay, so this is, I don't need the exact list, I was just curious what is somewhat officially supported. So it looks like they've got i386 Apple. Oh, that's iOS. Apple iOS, really? Interesting. Linux, Android, Apple Darwin, so you got like the Mac OS, iOS, Android, Windows G like GCC, and Windows Microsoft Visual C. FreeBSD, Linux GNU, Unknown NACL, MIPS, PowerPC. I mean, it's interesting that, I mean, is this still popular? I noticed Go does it too. Like, do they support it just because it's easy to support, or because people really need it? That's, I mean, that's, to me, I don't know what, that just reminds me of oldness. x86 stuff. Okay, basically all the same stuff. OpenBSD, NetBSD, FreeBSD, Dragonfly, Solaris, Windows. Okay. So cool, I should be able to compile to Linux, to Windows. So maybe we'll try... Actually, I'm going to link this in my little cookbook, because this is a pretty good resource. And I'm going to try it out. So let's create a new directory called cross-compiling. And we will add a README inside that folder, just to have a couple notes about this cross-compiling with Rust. And so what do you, there was, basically you can do cross-compile with the dash dash target equals flag. For example, it's like Rust C target equals, and let's pull one. Let's try the Windows one. I wonder if it'll work if I can do a Windows one. So let's try x86 64 PC Windows GNU. So I should need to do like that. And then I think that's it. That's how they described it. Rust C dash dash target equals blank. Yeah, something dot rust. Okay, so let's pull that hello world file, and I'm going to copy that over here as test.rs. And that's okay. There we go. So I just want it just like that, and I'm going to pull open the terminal. And so in the terminal, let's try, or we're cross-compiling directory. So if I do rust c test, okay, all good. Now we have a regular one. So what if we do, let's remove that one, and we do rust c -- target equals x86 x64 underscore 86 dash PC dash Windows dash GNU test.rs. Error loading target specification, could not find. Okay, so they mentioned this, and they mentioned that there might have been a package in apt already. So let's see, let's go back up to the top where they were explaining it. They said, okay, yeah, short Ubuntu example, rust up target add. Okay, so I have rust up installed. So we'll try rust up target add x86 underscore 64 tech PC Windows GNU. Okay, it looks like it's working and it's installing the cross-compile component. I guess it's probably installing the compiler components. Okay, so now let's retry the Windows compile command. Okay, same thing, same error. So did I type it in wrong? Configure cargo for cross-compiling. Maybe that's the recommended way to do it. Let's try their example then, because that rust c one. Yeah, so let's see. Rust c print target list. Oh, so maybe I typed it in wrong, because look, it says it's right there. x86 64 PC Windows GNU. x86 PC Windows GNU. x60. Oh, I did do it backwards. It's x86 64. x86 underscore 64. Okay, now let me make sure. Did I do my rust up target add right? I did that one right. Okay. So what is this? We're getting a little farther now. We're getting a different error. Linking with GCC failed. Okay, so they mentioned that there were some flags for linking too. So let's search for link. Oops. Linking. No, there had to be another one. Yeah, so requirements, a GCC cross-compiler, because Rust C uses GCC to link stuff together. So am I missing? I have GCC, but am I missing like a GCC Windows? So let's see, apt cache search, GCC grep win. No, nothing. Grep 64. Let's see what we get. Anything that looks like a Windows cross-compiling package. MinGW, actually, yeah, I think this might be what I need. MinGW 64 tools, because I was telling it to use the GNU toolchain, and the MinGW is the Windows one. There we go. GNU compiler collection for MinGW. So let's try that. Apt install GCC MinGW W64 base. Yeah, let's try that out. Okay, shouldn't take long to install. Yeah, it's already done. So I'm just going to try this compile to Windows again. Yeah, same thing. Wait. No, yeah, it's the same error. Unrecognized option. Enable long section names. What is that? That was specifically what it didn't like. LD error. Oh, there's, yeah, specifically with Rust. There's a GitHub issue on the Rust GitHub about this exact thing. Oh, there's a verbose. Maybe I should try that too. But let's see. This is a duplicate of blank. I'll open that one too. Looks like the wrong linker is being used. The compiler is using GCC. Oh, maybe I need to do also this -c. Okay, so I'm gonna leave that open. It's -c space linker. And then the linker we want is going to be x86-64 W64 Minji W32 GCC, and that's what we just installed with the apt package, I believe. No such file or directory. Oh. I think I need to put the Rust file at the very end. No such file or directory. x86. Okay. So it looks like I'm probably having the same issue. I'm still using the wrong linker. But do I have the right linker installed? Okay, well, I don't want to get too hung up on this right now. I wanted to see how easy it was because it's really easy in Go, and so it's turning out to be a little bit more challenging. A few more steps, and I'm close. I'm missing the right linker. So maybe. So what did I install? I installed GCC Minji W-W64. Let's try the full package. If I only installed the base, maybe it didn't install the linker. As soon as this is done, I'm going to try rebuilding it to see if that added the linker I needed. Oh, and it worked! Awesome. So, okay, I'm gonna make notes of this because that was a little tricky. So, I need GCC Minji W. Wait. I need the README in here. Okay. To cross-compile for Windows, install the GCC cross compiler and linker. For example, in Ubuntu, what do we do? Sudo apt install GCC Minji W64, and just to be safe, we can add the base too. I think base is going to get installed anyway, but I just want to be safe. So I think that was it. I think those were the only two things I needed to install, and then I was able to run. Oh, but I actually. So let me get some more screen space in the editor. So I also needed to do -c linker equals x86-64 W64 Minji W. Is that what it was? Okay, history. x86-64 W64 Minji W32-GCC, and we actually put the file name at the end. So that runs, and if we look, we've got our exe. and I have a Windows box I can test it, but I'm just gonna trust that it worked. So it came out to be 3.2 megabytes just for the hello world. But that's cool that we can do the cross-compiling like that. So now that we know how to do that, let's try a different target. Let's try the Mac. So let's go back and look at the list of targets that they showed. So x86, 64 Apple Darwin. Okay, so we're gonna have to figure out the tool chain for that one. I'm hoping that GCC just has a simple one, so I can just use Rust up as easily. So we're gonna do x86 64 Apple Darwin, and that should be for the desktop Mac and the laptops and everything. And so for the linker, I don't know if that's gonna be this. Well, hold on. I guess it'd be. I'll have to install the package and see, but actually, would we even use min-gw? So let me just try it without a linker, and it should error out. Can't find crate for standard. Oh yeah, the target's not installed. Okay, so we did rust up to install the target. So rust up target add x86 64 Apple Darwin. Oops, typo. Okay, 50 megabytes. Not bad. Let's try it again. Okay, now it's going to complain about the linker. So we're going to need the right linker, and what I'm going to do is search apt cache, search gcc grep Darwin. No, it doesn't look like they have. Interesting. Grep Apple? What linker do I want to use for... Well... Let's see. Let's try a Google search. Rust cross-compile Apple Darwin linker. What linker are people using? Oh, do I have to be on a Mac? Do I need to be on a Mac to use the proper linker? I cross-compiled from Linux to Mac. Okay, so someone did it. I just want to search for a linker. I want to know what linker they used. Linker. Oh. Worked our Mac build.shell. Well. Okay, cross-compile, cc, Mac OS. Oh, let me try gcc grep Mac. Mac OS, OS X. No. Let's just. Oh, Darwin. I did search for Darwin. Anything? Are there any GCC packages for Mac, or am I kind of out of luck? I wonder if I do have to be on a Mac. Well, that's not too important right now. I got the Windows one working, which is really cool. And it wasn't that much work. You just had to make sure you had the toolchain. So apt install gcc the min-gw to Windows, cross-compile. Oh wait, there was one more step here. Add the compile target with rust up. And then that is rust up target add, and what is x86 64. I want to make sure I get the right command. History grep rust up target add x86 PC Windows GNU. PC Windows GNU. Okay, so we can preview the RST document. Maybe. Maybe not. Okay. That looks good to me, though. Okay. Now we can call the cross-compiling one. Oh! Look at all those files it made. Okay, I'm going to add a gitignore file inside this directory. And we're going to ignore test.exe and they're all O. Those are all the linking files. Okay. Okay. That should be better. We got a couple notes on how to do cross-compiling. That's a good one. It's a good one to know how to do. Okay, I'm going to commit. Adding Rust cross-compiling example. Okay, cool. Okay, cross-compiling example done. Let's go back to our list. Actually, one last thing I want to do is add that link, references. Okay. Now what else? Making database connections, wrapping C libraries. Yeah, that one was something I wanted to see. And I was asking around if you can link between the objects pretty easily. Like if you can just compile the object files and link pretty freely between the C ones generated. And they were saying yes you can, so that's what I'm interested in doing next, I think. Because I don't foresee doing myself much game programming or GUI programming in Rust, but I do see a potential need or benefit in doing some low levels like C interoptions, writing libraries that work with C, or wrapping C libraries. I think that's probably where I would use it if I found myself with a use case for Rust. So it would be nice to have examples of doing those kind of things. So let's delete some of these things out of our folder. Even though we ignored them, I just want to clean it up. Okay, so how about linking? Which one would be easier to start with? Linking with C files or wrapping existing C libraries? Let's try the linking, and then we'll probably build a simple C library, and then we can figure out how to wrap our own library. So I think we'll do that. New directory, and we're going to call it wrapping C. No. We'll just call it linking with C. We may change that name later. But I'm gonna need a C file, right? So we'll make we'll make this one we'll have a main Rust file, and then we'll make a library in C. We'll call it mylib. And this C library is just going to have a function, right? We don't want a main. We just want like a library function. So we'll say, how about return an int, and we'll call it multiply. Okay, and then we'll just return x times y. Actually, and why not? We'll because I included standard I/O, so why not? Just to make sure it's running and everything, and to make sure it links with standard I/O and all that good stuff. Multiplying this by that. And we do want to return the value. And we'll print out the value that gets returned. in the main Rust file. So that looks okay. Let's go into our linking with C, and we'll say gcc mylib.c, but we only want it to compile without linking. And I think I might have notes about this already, so let me check. Compiling tips. Wait. Oh no. No. That's not helpful. GUI options, no. Okay, looks like I don't. Okay, Google, help me out. I want to compile without linking. What's the GCC command to do that? Maybe the man page will help me too, but C man gcc -c. Okay, we'll trust it. So we'll say gcc -c mylib.c. Oh, printf, not print. Okay, so now we have the object file. So that's our C library, and now we want to link. Now, yeah. So how do we call a C library from Rust? Foreign. Okay, so this is the official Rust documentation. Foreign function interface. This guide will use the snappy compression and decompression library as an introduction to writing bindings to the foreign code. Okay, so that's what they're going to wrap, essentially. A note about libc. Many of these examples use the libc crate, which provides various type definitions for C types, among other things. If you're trying these examples yourself, you'll need to add libc to your cargo.toml. Okay. I will... Well, let's see. I guess the proper way to do it is rust up... And what is it? New? Rust up new. Rust up new... test? Shoot, what is that command? Cargo new project. Cargo new, we'll call it CWrap. Yeah. Okay. And we'll just delete this one, it's empty. Okay, so now we have our new project and we've got our cargo toml file where we can paste our libc dependency. Okay, so calling foreign functions. The following is a minimal example of calling a foreign function which will compile if the other library is installed. Use libct, okay. Okay, so you define extern and you have to give it the link name. I guess that's the equivalent of doing a -l. You're doing like a gcc -l pcap or -l snappy. I guess that's how you kind of... I don't know if that's really a comment or if that's like a special preprocessor directive that actually... I'm guessing that actually gets parsed. It looks formal. And... okay, so they just define the external function. They call it using unsafe. I guess you always have to call unsafe if you're calling C code. That kind of makes sense. Okay, so let's see, where do we start here? No cargo projects found? Okay, let's attach one for this. Let's attach... yeah, the one we just... is that how I do it? But yeah, it's indexing. Okay, so that'll be a little more smarter about our dependencies. So what do you have to do? Extern create libc, and then size t libc. I want a libc int, I guess. Int. Can I just do a regular int? A c int? cu int. I'm guessing c int, because that's all I took in was in my library. I took in just a regular int. So I think that's what I need there. Okay, so then I need to define that external function that's called multiply. Is it like that? No, it's so you do extern, and then I guess you define all your externals in a block. And the one I want to define is mine called multiply. And there's an x, which is an int, and a y, which is an int. Actually, it's a c int, I guess. So it should be more appropriately, I think, like that. Okay, and oops, go back. So then I can say let the product equal, oh, I have to call unsafe, multiply, and we'll give it like 6 and 4. Call to unsafe requires unsafe function or block. Okay, alt enter, add to unsafe function. Oh, no, they didn't do that, did they? No, they... Hold on. Okay, they wrapped it in a block is what they did. Okay. So that looks better. So, is that it? Is that all we need to do? Now, I probably need that object file in the same directory, or I need to tell it where to find it. Oh, I'm probably going to need this link, yeah. So the extern block is a list of function signatures in a foreign library. In this case, with the platforms C, ABI, the hash bracket link attribute is used to instruct the linker to link against the other library, so the symbols are resolved. Okay, so what I'm going to need, where do I put it? Right above the extern. Okay, so these are specific to this extern, so it's hash bracket link, and then you pass it the name, and we said name equals, and is it in quotes? Yeah. Name equals, what did we call it? MyLib? Okay. So is that it? Then can we just do the excited print line? Okay, foreign functions are assumed to be unsafe, so calls to them need to be wrapped with unsafe, as a promise to the compiler that everything contained within truly is safe. C libraries often expose interfaces that aren't thread safe, and almost any function that takes a pointer argument isn't valid for all possible inputs, since the pointer could be dangling, and raw pointers fall outside of Rust's safe memory model. When declaring the argument types to a foreign function, the Rust compiler cannot check if the declaration is correct, so specifying it correctly is part of keeping the binding correct at runtime. The extern block can be extended to cover the entire Snappy API. Okay. Yeah, so you define all the functions in one extern block, and you specify where it's coming from with the link. So I want to try it. Now, what is cargo run? I guess it's cargo build. Okay, now I'm expecting it to fail because it couldn't find... Oh, I guess I need... I'm expecting it to fail though because it shouldn't be able to find the library that it's trying to link to. Yeah, good. So it's doing a -l mylib, which is what I wanted to do. So let me try copying in this .o file into the project directory. And I'm going to add a .gitignore to ignore all the .o files. Okay, so let's rerun it again. Okay, it still can't find it. Now, let's see. Am I doing it right? Now, wait, do I have to do like libmy? If I do libmy and then you like, because if you do link pcap, it's lib pcap, but you're only linking pcap -l pcap. So I don't know if it's going to expect that prefix on the file and everything. So let's try it that way. No, that didn't seem to help. So just to make sure I understand I'm doing this all right, let me go back here. And I'm going to make a C file. Let's see. C call external link live. Let's make sure I fully understand it and make sure it works in C. So, how do you do like an extern? Do I need a header file? I don't need a header file because I'm defining it in the... Where is it? In the main.rust file, I'm defining the header essentially. Hey Mythic, welcome back. It says, ooh Rust, how's your day going so far? Hey, it's going pretty good. I'm just exploring Rust and I'm taking on some of the tougher ones. So we just looked at cross-compiling in Rust and we were able to cross-compile a windows.exe. And now I'm looking into how to link with C libraries and like wrap C library functions. So I wrote a one function library and created the object file, and I'm trying to link to it from Rust. And so I created the extern and told it to link, and it's having trouble linking. So I wanted to do a quick C version just to make sure my library actually works when I link it with C before I try and link it with Rust, just to make sure I'm not doing something blatantly stupid. But I guess I'm gonna need a header file if I'm gonna do it in C. Well, I guess I could put it like in my... Where is it? I made a test.c. Didn't I? No, not yet. Okay, so let me try test.c. Okay, so we're going to include standard IO in this one. Int main, int argc, corner argv, and we'll say return 0. Okay, so we want to call our function multiply. Well, let's do this. Int product equals multiply 64 and print the product. So if we build that, it should probably fail because it's not going to know what multiply is, even if we link it. So if we try like gcc test, yeah, it doesn't know where it is, but if we try linking with my... Okay, now if I do that, I also have to say -i dot. I have to tell it that the include directory is gcc specify link directory. Actually, I have, let me see, I've got a tutorial on how to link C in assembly code. I did it, yeah, what, in 2015? But I think this might have some helpful functions. Okay, xturn. So I do have to do the same thing here. I have to say xturn multiply. And do I have to do the parentheses? Yeah. Okay, so now let me try GCC, it should fail. Now if I link it with my library, let me rename this now. Move mylib.o libmy. Type oh, it's just a warning. No, now it says yeah. Cannot find. Oh, I guess it's int. Do you define it like that when you do an xturn? -o hello. Oh, I just give it, I don't have to do a -l, I just give it the name of the object. I think that's where I'm kind of brain farting. I don't do C stuff all the time. And again, I do it to kind of keep fresh and make sure I don't forget all this stuff, and so I do it kind of as an exercise. So I want to compile that, and I want to link it with libmy.o. Okay. Boom. It worked. Okay. So that's how you link, that's how you do it with C. And here we'll say compile with gcc test.c and mylib.o. Okay. So let's see. I got it to work with C now, but it wasn't with the -l flag. It was just by, I just added the object file to the linker. So, I mean, what if I just do my libmy.o? If I give it like the actual file name, will that work? crap, we'll do cargo build. Yeah, it's still trying to do the -l, which is no good there. Okay, so cargo xturn. So let's see if there's any more documentation here that might be helpful. No, come on. There's got to be something. Well, so this will work for libraries that are like installed to, where is it? User share live. User share live. Let's see. So where would I need to put that library if I wanted to put it in like a user local lib? Let's try. Okay, so okay, now let's try copying that library. libmy.o. Now, I'm not really convinced that will do it, but let's look at the whole compile command that it's giving it. Anything stand out? No, it's just figuring out if I don't want to do a -L and I just want to add, can I just add an object file to the toml? In the toml file, let's see, rust specify.o object file for linking. It looks like there's indeed a way to do this. If you build all the C++ code into a static archive, you can link it like this. You may also be interested in the GCC crate, which is generally used to compile C++ code and link it to a cargo project with no extra print line directives needed. Interesting. Print line directives. So where do print line? What do print line directives? That seems like such a weird way to do things. I mean, is that really what you do? Do I put it in main? Do I put it up here? I mean, it doesn't make sense to put it inside main if it's something that happens at compile time. And okay, so let me look up this Rust link live. Okay, so let's see what they've got to say here. There are a few special keys that Cargo recognizes. Rust link live, yeah, so I got a dynamic, well, yeah, .o is technically a shared library, right? So it's a dylib default. The optional kind, okay, so we can just say Rust. Now where do I put that? Build scripts. Some packages need to compile third-party non-Rust code, for example, C libraries. Other packages need to link to C libraries, which can either be located on the system or possibly need to be built from source. Okay, I wouldn't mind building it from source, that'd be fine. Others still need facilities for functionality such as code generation. Cargo does not aim to replace other tools, but it wants to integrate. The Rust file designated by the build command relative to the package root will be compiled and invoked before anything else is compiled, allowing your Rust code to depend on the built or generated artifacts. By default, Cargo looks for build.rs, even if you don't specify it. Use build equals blank to specify. For examples, some use cases of the build command are building a bundled C library, finding a C library on the host system, generating a Rust module from a specification, performing any platform-specific configuration needed. Okay, well this looks like what I want, because I do want to build a C library, and it looks like this is what I need to do. Outputs of the build script. All the lines printed to standard out by a build script are written to a file like blank output. Okay, so it's starting to make more sense now where these print lines go. They need to go inside the build file. And what we're outputting basically is, and that was optional, so we can just say my, because it's lib my. Okay, Rust link search native path to where lib is located. Excellent, excellent. Now this is going to be home nano cookbook Rust linking with C, and we're inside this project called CWrap right now. Okay. Now will this do it? Now if I do a cargo build... Ooh, it's getting further. Caused by macro expansion? Oh, it doesn't like my build script. What does it not like about my build script? No. Yeah, build.rs. Oh, do I need like a main function? Right. It's still a normal Rust file, I suppose, so it still needs like a function main. And we'll just do that. Oops. Okay, I think that'll be enough. Could not. Yeah, so it still wants. Let me see here. Link live. Maybe that's the file libmy.o. Is that what it wants? The actual file name? No. Okay. Let's see. I'm not 100%. I'm pretty sure that it's gonna cut off that lib prefix, and so when I refer to them, it should just be like it's my. So it should at least be setting the search directory properly for the library. But what else is there? Okay, so there's a link. Well, you know what? Maybe it is looking for a. Well. It says it's looking for a dynamic library. So maybe if I try a static library, it'll be easier. Because then it'll be embedded inside the executable anyway, and that'll be better. So what if? How do I do gcc compile static lib? I think you just give it an extra flag to tell it to compile to basically a .a. Instead, create the object files gcc static library. A static library is basically a set of object files that were copied into a single file with the suffix a. A static file is created with the archive or AR. Okay, so I'll try that. We'll try archive libmy.a, libmy.o. No, that didn't. I don't think that was what I wanted. Okay, it didn't like. I'm gonna give this thing a better name instead of just my. Okay, so I'm gonna delete these built object files that I don't want anymore. I don't need the a.out. Okay, so I want to go up a directory, gcc test. No, and I'm gonna move my lib, so that's gonna be a lib rust wrap. And so we're going to gcc-c to just compile lib rust wrap. And then we have lib rust wrap.o. So now let's say lib rust wrap.a, lib rust wrap.o. Yeah, okay. Did I do it backwards? Hold on. Static. Create a static library. Oh, it's kind of like tar. You got to say create file. So you got to do RCS. RCS. Interesting. So it's trying to look. it's trying to look in the default library, I think. No, it's right there. Yes, so here it says create the lib. So we'll just call it Strat. I'm gonna try and follow kind of how they have it. Path steps to create static library. Man, archiver. S at an index. What's R? And C. I don't see it. Okay. Yeah, so that's how they're doing it. Okay, but they don't call it lib. Yeah, so let's see. RCS, we're going to call it lib rustwrap.a, and we're going to throw in rustwrap object. So I don't understand why it's having such a fit. I wanted to create this file in this directory based off of this file in this directory. Unsupported file? Interesting. Why is it unsupported? No. It's Am I missing something? No, I think this... Okay. So still trying to work out how we wrap a library. So I was trying to wrap our own library, but you know, maybe a better exercise, since this is turning out to be troublesome, is first wrapping one that we know works and know exists, right? Like pcap. So let's actually try to wrap a pcap function. And we'll just do one simple one, like a device lookup. Well, that one's got some strange types. I'd rather do one that has a real simple type. What, like printf? See standard library functions. Let's look for an easy one. Taking suggestions. Any good? What would be a good simple C library to wrap? I guess we can look in user lib and look at all the libraries we have here. So what do we have? Let's see, I guess there would be a libc. JGS. I'm not seeing anything that looks really attractive to try and wrap. I guess we can try and do what they did. They did snappy. I mean, why not? We'll just go with with their example. If I can find it anymore. Yeah, here it is. So we'll see Ubuntu snappy package. Live snappy, I guess is what it would be. Okay. Lib snappy? Yeah, here we go. So, apt install lib snappy, let's try that. Apt cache search lib snappy. There we go, lib snappy 1.5. So let's install lib snappy 1v5, lib snappy dev. Okay, so let's do like they did. What we're going to link with is one called snappy, and actually if we do ls user lib grep snappy, we should see no user local ls user local lib. It may be somewhere else, but I'm not going to look for it. Okay, so we should have it installed. Now let's try their example. Snappy max compression. And so we actually want to use size t, libc size t. Yeah, Mythic, you're probably bored. I've been stuck on this one for a little bit. But again, the reason I'm spending all this time on these is because I think that if I ever have a Rust use case, it's probably going to need to involve something like this. It's probably going to involve interacting with C libraries and potentially cross-compiling. So if I can knock those out, I feel like it'd be a good feat, and I'll have some good cookbook stuff. And then like these other things will be a little easier to figure out because I'll just be figuring out Rust packages and how they work. So this will also give me a deeper understanding for how Rust works and how the packages link together and everything. So then here we're just going to call snappy max compressed length and give it, what do they do? Just give it a length. Yeah, we'll give it a 64. Okay, now the only thing we have to update is the toml file. Actually, I think that's fine. So, oh, and my build, this build script, I don't think I need it anymore at all. I'm just going to delete it. Okay, now I'm going to try cargo build inside the crap cargo build. And it actually worked. It worked just fine. Okay, so wait. Target, ls target. Target, debug, crap. Boom. Answer. Okay. Okay. So that worked. And I want to rename this wrap clib. And I want to add a git. Oops! I want to add a git ignore, and I want to ignore the target and any O files again. Okay. So I'm gonna create a new folder again. Let's see, I'm going to move this wrap lib with C out into kind of the root. Okay, so linking with C. And then I'm going to have one called wrap clib, yeah. So wrap clib. Oops. Wrap clib has our example. Of how to wrap a C library that's in the normal installed library directory. Now the problem I was having was linking with C, and so this is what I'm going to do. I'm going to start a new one. I'm going to rename this real quick. old. Cargo new, linking with C. Okay. Then I'm going to copy over from the toml the libc dependency. And I'm going to create a build file. And then I still want my multiply function, but I'm going to rename it. We're just going to call it multiply.c. And I'm going to put that in a separate folder inside here, and I'm going to call it C library. And test.c will still call it. So we have an example of how to use it in C, and we know it works. And we're going to keep all of that isolated in its own directory. Okay, so I want to go inside this linking with C and inside the C library. And here's where I want to GCC my multiply. And we now have our multiply.o. So now we can do gcc test.c multiply.o and it should work just fine. We get a warning, but that's okay, it still runs and it still works. So now where's the a.out? Show up. Oh well. Okay, so let's attach this to the new project we made. Linking with C, cargo.toml. Mythic, have you ever done any Rust? Project does not exist. Okay, let me start closing Windows. I've got too many tabs open. Okay, so we've got a C library with our object file and everything in that folder. Now what we need to do is have Rust call it and be able to find it when it links. That's really what the problem was. And so they gave us some directives. Now what about this? Callbacks from C code to Rust functions. Some external libraries require the usage of callbacks to report back their current state or intermediate data to the caller. It is possible to pass functions defined in Rust to an external library. Okay, that's cool. So you can call Rust functions from in C. The requirement for this is that the callback function is marked as extern, so that I guess C also understands that it's coming. Okay. Link name equals xlib. And then down here, this is the external library. Okay. I'd like to see if they have any tips on the command line commands you used to do this. Here we go, linking. The link attribute, this is where I had the big problem, is linking. Right, so we can even try it. So what did we have to do? We had to say use, let me pull open the other one. Extern create libc. And in our example, we're using libc cint. And then we're calling, well, we have to define the external. So we've got extern, a function called multiply. That returns a cint. Is that how you do it? Cint multiply cint. Hold on, let me go open the other one again. So in this one, yeah, extern funct. Oh, the return's at the end. Okay, so it's x, cint y, cint, and at the end it returns another int. And it's like this. Okay, so now we have that. We also have to label the external. So we do hash bracket link name equals, what did we call it? Multiply. And then if we call here, we can say like let product equal unsafe, and then we give it a block to work in. I guess we do it on the same line and say multiply. I don't know, 6 and 4. And then we'll print the product. And so if we try and cargo build that, I think it's going to fail. Yeah, okay, so same problem we were back at before. Cannot find multiply to link with. I just wanted to build with that file, so let's see. The link attribute on extern blocks provides the basic building block for instructing Rust C how it will link with the native libraries. There are two accepted forms of the link attribute today. Name equals blank, and kind equals blank. In both of these cases, foo is the name of the native library we're linking to, and in the second case, bar is the type of native library that the compiler is linking to. There are three currently known types: dynamic, static, and frameworks. And it looks like dynamic is the default one. The different kind values are meant to differentiate between how the native library participates in linkage. From a linkage perspective, the Rust compiler creates two flavors of artifacts: partial and final. Okay. Native dynamic library and framework dependencies are propagated to the final artifact boundary, while static library dependencies are not propagated at all, because the static libraries are integrated directly into the binary. A few examples of how this model can be used are a native build dependency. Sometimes some C code is needed to glue things together when writing Rust code, but distribution of C code is in a library format that's burdensome. In this case, the code will be archived into libfoo.a. Okay, libfoo.a. And then the Rust crate would declare a dependency link name equals foo, kind equals static. Yeah, so this is where it's like it needs it to be named lib multiply. But that's not enough. It still needs to know where to find it. And that's where those print line directives came in. So let's see. Rust link specify library, or directory, I guess. Advanced linking. No, so there were some print line directives. I lost them now. Wait, maybe it was on this page. I think this is where I just was. Let's see, so callbacks, targeting callbacks, that's okay. Linking, yeah, we just went over this. Calling Rust code from C, yeah, we looked kind of at that. Okay. Rust build.rs specify link directory. Build script, here we go. Rust, yeah, Rust C link search. Okay, so in the build script, I think I have to print that out quite literally. And in this case, it's home, nano cookbook, Rust, and we are in linking with C, and I want it to search in /C library. Now, which other ones were there? Were there any other ones I needed? Cargo, Rust, link, lib. Let's see. Link lib, and it's dilib, and it was optional, so we'll just do that, and it's called multiply. And I'll probably put that after we add the search directory. So we'll see if that helps it find it anymore. No, it still has trouble finding it. And I'm getting stuck on this. Now, maybe I don't need the cargo prefix, because it didn't look like it had that before, actually. Yeah, no difference. And what if we try with verbose? Yeah, still no luck. Let's search for, maybe someone has a tutorial on this. We'll do Rust, linking to C library. And let's check out maybe this forum post. Because I'm missing something. I'm getting close, but there's something that I'm missing, and because I'm having trouble getting it to find outputs of the build script, cargo, Rust flags. Yeah, so this person suggests the same thing as I was doing before. In addition to possible path issues, you need to actually make a static library using R rather than just having a .o file. So, is that true? I have to do that? I don't think I have to, but I'll see if that helps again. So I'm going to move live multiply to just multiply.o again. And I'm going to create the archive live multiply.a with multiply.o. Now, why does it need my... I guess it's actually going to install it? Is that what it's doing? Why does it needs my password to do some sudo stuff? So is it like actually? Yeah, no. This something's weird. R is an apt command? No. That must be an alias. Maybe that's why I'm having so many problems. Oh man, there's an alias. How do I unset an alias? That's why my archive program's not working. Unalias. So is that really? So let's try this again. Multiply. Oh boy, that's a kicker. Ubuntu had an alias that overwrote an important program that I actually needed. AR to archive. Okay. Let's see if that works. Let's see if we have any better luck now. That'd be. I hope we do. Carbo. Okay. Yeah, still no dice there. Let me make sure that this path is correct. Yeah, and lib multiply.a. Dot cargo build. Come on. How do I do this? Now maybe I do need the cargo back. Oh, it worked! Yes! Victory! Watch this, I'm gonna do a little panda victory dance. Oh, yeah. Yeah, we got it working. Okay. So I need to take notes. I need to take all these notes before I forget. Okay, so linking with C. Let's add a little readme here. And what did we have to do? Okay, to link with a C lib, do this. What do we do? What did we do? Okay, first we need to make the C library. Gcc myfunctions.c. Actually, we just want to do -c. We'll do -o. We'll just call it myfunctions.o. And then you got to create the archive to make static lib. And so that is archive. We'll make a note about double check Ubuntu alias is not overriding. Okay, so this is linking with C libraries in Rust. Okay, to link with the C library, we make the C library, and then we create the archive with archive, and we'll call it lib myfunctions.a out of myfunctions.o. And then we have to, in the Rust file, we have to add extern. We have to do a lot. Okay, we're gonna have to add extern. Actually, okay, let's make it a bullet list because we have a few things to do. In the Rust file, we need to add all external functions at the top with extern block, right? So we have to create this extern block and define all the functions. And we also have to add a link. What do we call it? I'll call it a decorator, like that. And in this case, multiply, it's going to be my functions. Okay, on top of that, we have to add extern create for libc and use libc cint and all other data types needed. Okay, and then when we call, okay, when calling the C function, wrap in an extern, I don't know, an unsafe block. Okay, so those are kind of the key things that we have to do in the Rust file that we're calling the C from. We also need to add a build.rs file for cargo and include let's see, the link directory. Now let's see, do I even need this second line? Do I need that? Let's see, can I cargo build without it? Yeah. So I actually don't need the second line because that's being defined in my here with the link decorator. Now, interesting. I wonder if I put that there, can I leave this one off? Oh, I can. But I can't leave both of them off. Oh, okay, so let me do this. In the README, I'll say, add a link decorator, or set the link in the build.rs file. Like this. Okay. And I'll monospace a couple of these things. Let's see. Okay. Okay, this is starting to look good. All these notes are going to be really helpful because it took me, what, like an hour to sort through all these little details. So next time I have to do this, I'll have some good notes. Okay, and right here I'm going to say not required if the link name equals multiply. Decorator is being used in the main Rust file where it defines external functions. Okay. Now, so the real important one here is this rustc link search. That way it knows where to find the files. Because I use a custom library that's not installed into my normal default library folder, it needs to know where it is. Okay. Excellent. So now we have a couple examples. So I have this one here that we took from the official docs called wrapc library. And this one shows how to wrap a library that's installed. And actually here I'll say in Ubuntu, it's sudo apt install libsnappy1v5 and libsnappydev. And so that's how you wrap a library that's kind of in your normal library stuff, like installed into your system libraries. And you don't need a build.rs file for that. You can just do it like this. It automatically looks in your default library directory. So that's the wrapc library. And then I have this other one called linking with C, which is basically the same thing, except it's being done with a custom C library that lives right here. And so the trick there was figuring out how to tell it to look in our custom directory for that library that we built. And so it turns out you need this custom build script to do it. And okay. And include this. Let's see, so it's function main close cargo rustc link search native equals home path to dir with libs. Okay. What else? We also need to, in the cargo.toml file, add a dependency for libc. Okay. Okay, so this looks awesome. I'm really happy we got that working. So I'm going to clean up and I'm going to commit. I'm going to commit this. I need to update the git ignore, make sure I don't. Let's see. So I want to ignore the targets. Yeah, all the O files. A.outs. I'll leave the libmultiply.a and the. Here, I'm going to make compile notes. And that's going to be gcc-c multiply.c-o multiply.o archive, create the archive, live multiply.a out of multiply.o. And then we're good. So this is going to be compile shared lib, create static lib, and actually now I wonder if I can interesting. I wonder now that I got that sorted out if I can go back to the dynamic library. So in the main file, no, I think that's enough for now. And then what else? To compile test.c, which consumes multiply.o. Use gcc test.c multiply.o, like that. Okay, I got the notes that I need there. That will help me get back to where I was before if I come back and look at this in like a year from now. I think I've got enough notes to help me get back on track and figure out how to get back here. Okay, so let's do a git commit. We'll look at the status. I want to commit all that stuff. That all looks good to me. Double check with the git status, make sure there's nothing weird that I don't want to commit. That all looks good. So we're going to say git commit, adding C wrapping and linking examples. Let's see. Since this is a larger cookbook, I'll say adding rust/C wrapping and linking. And I'll go ahead and push. Git push. No. Okay, I'll push it later. Or rather, I'll do this. Git remote, remove origin. Git remote, add origin SSH. / git at github.com /devdungeon /cookbook. I think that'll do it. Yeah, there we go. Okay, so now if we go to the GitHub, we can check out the cookbook and make sure that all our Rust examples are now up there. And yeah, there they are. So linking with C and wrap C library. Excellent. Excellent. Those were two of probably the hardest things on my list that I wanted to do. So we also looked at, wrapping C libraries. So we can move this to our completed topics list. And we also covered linking to C libraries. Linking to custom C libraries. Okay. Awesome. Now that we finished that, I think I'm gonna. We're going on almost 2 hours. I'm gonna take a 5-minute break, get some water, stretch my back. If you all have been sitting around too for almost 2 hours, I recommend you also take a stretch, get some water, and I'll be back in about 5 minutes. I'm gonna play some music and put up an away screen. Be right back. Alright, everybody, I'm back. So, where did we leave off? We just accomplished a couple good things. So, today, and I guess I'll just recap in case anybody just joined. Today we're looking at Rust. I'm building a cookbook, and I'm just building up snippets and examples of Rust that I think will be useful and will be good for learning the language. I don't know the language very well. I've only looked at it one other time, and that's when I sat down on another stream to do one called Learning Rust from Scratch. And in that one, I accomplished all of these bullets up here. So everything from installing it to do the hello world, adding dependencies, getting user input from standard in, taking command line arguments, reading and writing files, creating a TCP client and server, making HTTP requests, parsing JSON, packet capturing. So accomplished all of those examples in the first sit down. And today I wanted to dig in a little deeper and start to explore Rust some more. And I haven't come across any particular use cases. I've been using Go a lot when I need something that's really performant, and it's been good, and it's been adequate for everything I need to do. But Rust is supposed to have a little bit more. It'll give you a little bit more freedom with the memory while also being incredibly safe. So I think if I ever have a use case, it's probably going to be doing something relatively low level. So what I wanted to look at then, and what we did earlier before I took a break, is these 3 bullets. So we looked at cross-compiling, and I was able to figure out how to compile a windows.exe from my Ubuntu machine here. And then we looked at wrapping C libraries. And so I got an example of wrapping a C library that we installed using a system package, using apt to install a package down to our normal system install directory. And then we looked at writing our own custom C library that was just compiled into a local directory totally outside of the normal library directory, the system libraries. And that was a little tricky because what you have to do then is you have to create a Rust file called build.rs that prints out the config file for your build. So it's a little meta, but I figured it out, and what you need particularly is to set some directives like this one where you tell it where to search for link objects. So once you set the link search directory, then it's able to find the library as long as you have the right naming conventions and everything, and you want it lib_multiply.a, libx.a is really how it wants it. But we got that working, so we were able to cross-compile, wrap C libraries, and link with custom C libraries. And once it was all sorted out, it's actually not that bad. I actually kind of like it. I like how you can just create the C thing you need. So you say use libc, and in this case we were using an int, but like let's say we were using a car. Yeah, so we'd have the C char, or if we were using a float, we would do C float. So it's pretty easy, it looks like, to pull in the C data types and then just define your external functions and structures. And actually, I only looked at defining a function here, and I didn't look at structs. So that might be another step later on. I'm not going to do it right now, but how to pull in a struct or a special data type. I wonder if it is just as straightforward, if there's another little syntax for that. But anyway, now that we've got all that, I pushed all that up, and if you're curious to look through any of that code, go up to github.com/devdungeon/cookbook, and then in there are folders for a bunch of different languages, and just go down to the Rust folder and click on the Rust folder, and it's got all the examples that we've done so far. And the new ones we added are the wrap-c-lib, linking with C, and cross-compiling. So now we can go wherever we want. The rest of the topics I had on the to-do list were all pretty low priority to me. So I think this is how I'd separate it. I'd say multithreading and figuring out how to package libraries and publish them are probably the next most interesting things to me. And then after that, maybe how to do spreadsheets and databases. So I'm going to start by looking at multithreading. And let's see how they handle that. Let's see if it's pretty easy or not. So Cargo will start a new project with Cargo new multithread. Okay. Now we've got a new project with a main Rust file, and let's tell IDEA which project we're working on now. So we'll give it the Cargo toml and open those up. So these are our two main project files. And I have no idea how to do it, so we're going to check out the documentation. Rust docs multithread. And yeah, perfect. Let's look up their... And actually, I've been pretty happy with their documentation. Their... what do they call this? The book. Yeah, they have a book. And it's pretty good. It's had good documentation. And good examples. I've actually liked that. So, oops. Where are we? I went too far. Fearless concurrency. So let's go ahead and read how they do it, because I like how they do it in Go very much. So I want to see if it's similar. The second edition of the book is no longer distributed with Rust's documentation. Oh, go to the current version of the book. Okay, no problem. Go to the current version, and let's go to the same chapter. Fearless concurrency. Handling concurrent programming safely and efficiently is another of Rust's major goals. Concurrent programming, where different parts of the program execute independently, and parallel programming, where different parts of the program execute at the same time, are becoming increasingly important as more computers take advantage of their multiple processors. Historically, programming in these contexts has been difficult and error-prone. Rust hopes to change that. Initially, the team thought that ensuring memory safety and preventing concurrency problems were two separate challenges. Over time, the team discovered that the ownership and type systems are a powerful set of tools to help manage memory safety and concurrency problems. By leveraging ownership and type checking, many concurrency errors are compile time errors in Rust rather than runtime errors. Cool, that sounds good. Therefore, rather than making you spend lots of time trying to reproduce the exact circumstances under which a runtime concurrency bug occurs, incorrect code will refuse to compile and present an error explaining the problem. As a result, you can fix your code while you're working on it rather than potentially after it has been shipped to production. We've nicknamed this aspect of Rust Fearless Concurrency. I like it, okay. Fearless concurrency allows you to write code that is free of subtle bugs and is easy to refactor without introducing new bugs. Note, for simplicity's sake, we'll refer to many of the problems as concurrent rather than being more precise by saying concurrent and or parallel. If this book were about concurrency and or parallelism, we'd be more specific. For this chapter, please mentally substitute concurrent and or parallel whenever we use concurrent. And I guess it should be noted that the big difference between concurrent and parallel is that parallel, this is my understanding, parallel is when they're actually running at the exact same time. Concurrency just means you can have multiple threads executing at the same time, but not exactly at the same time. So like, example would be if you had one CPU processor. If you had one CPU and you were doing multi-threading, you are doing concurrent programming because you're running multiple threads, but only one is ever running at a time. And parallel would be if you actually had like eight CPUs running at the exact same time. Many languages are dogmatic about the solutions they offer for handling concurrent problems. For example, Erlang has elegant functionality for message passing concurrency, but only has obscure ways to share state between threads. And that's really the... where is it? Sharing state between threads? That really becomes the challenge when you are doing multi-threaded stuff. And the other day when I was doing the TCP SYN scanner, that's something that I was having to think about in C is, okay, if I've got these two threads, do I use a shared pointer to point to a piece of memory to communicate between them, or what do I do there? And in Go they have channels, but in here let's see how they do it. Supporting only a subset of possible solutions is a reasonable strategy for higher level languages. However, lower level languages are expected to provide the solution with the best performance in any given situation and have fewer abstractions over the hardware. Therefore, Rust offers a variety of tools for modeling problems in whatever way is appropriate for your situation and requirements. Here are the topics we'll cover: how to create threads and run multiple pieces of code at the same time, message passing, where channels send messages between threads. Oh, so they use channels. I wonder if it's just as easy as it is in Go. Can't wait to find out. Tune in the next chapter. Shared state concurrency, where multiple threads have access to some piece of data. Okay, and sync and send traits, which extends Rust concurrency guarantees to user-defined types, as well as types provided by the standard library. Okay, next chapter. Using threads to run code simultaneously. Okay, now I'm going to skip through. I just wanted to read that first page pretty thoroughly. So here's the example. To create a new thread, we call thread spawn and pass it a closure. Okay, so let's try this out. Let's go back into our editor and let's see. Let's do a starting application. And at the bottom, we're gonna do application finished. And then we're gonna try some multi-threading. Thread spawn. Okay, so thread spawn, and inside of it we pass it this closure. So we're gonna say no arguments, and then a block of code, and then do whatever we want. So we'll just say print line hello, and then a sleep. How do you do a sleep, like a timed sleep in Rust? Thread sleep? Interesting. So just thread sleep and... oh, interesting. So they use a time duration too. I like that. I like the duration class objects. So we got thread sleep, and what we want to pass it is a time duration. So we'll say time... what is it? No, it's time : duration. And we'll say we'll do the same thing, from milliseconds, and we'll say 1,000. Okay, we need some imports. Awesome. If we do Alt-Enter, Intellij knows what we want. Ooh, do we want core time or standard time? Let's go standard time, that's what they're using. Standard time. Okie dokie, so... interesting. So let's see. What do we think would happen if we ran this? It's going to spawn the thread and then it's going to finish. And it's not going to wait for the thread to finish. We need to do, if we wanted it, we probably need to do some kind of thread.join. So let's run it and see what happens. Cargo run. Yeah, boom. Starting and finished. It didn't even launch the hello. Do we have to start it? So we spawn it. Wait, no, this is the sleep page. We spawn it. Okay, so we don't need to call. We just need to have it wait, I think. So let's try in the main thread. I'm assuming the main is considered in a thread. And we'll say from secs. Yeah, from seconds we'll do 3. Oh, and and then we'll do another print. Okay, so let's try this. Okay, so that worked a little better. Now we've got one thread going in the background saying hello, and then our main thread waiting. Now, I wonder if we can say something like this, new thread equals that, and then do like new thread dot wait or join. So let's see, waiting for all threads to finish using join handles. Thank you, that's what I was looking for. The code in listing 16.1 not only stops the spawn thread prematurely, most of the time, but also can't guarantee that the spawn thread will get run at all. The reason is that there's no guarantee on the order in which threads run. We can fix the problem of the spawn thread not getting to run by using join. Okay, the return type of thread spawn is join handle. So that's what we've got when we said new thread. We'll call it the thread join handle, just to be a little more accurate and explicit for our example. A join handle is an owned value that when we call the join method on, will wait for its thread to finish. Okay, so we can say here like all threads launched, waiting for completion. And then we'll say thread join handle. Actually, maybe we need to do let thread join handle, then thread handle dot join, like that. Okay, so then it's going to say, okay, wait till the thread has synced up and finished. Okay, awesome. And then right here we can say print line thread has completed. So what is this error? It's giving me a warning or something. Unused result. That must be used. Why must I use it? Rust, why must I use it? What do I need to do with it? It just gives me something that says, you must use this. Okay, what do I need to do with it? You must use it. Let's see. Okay, unwrap. That's what we need to do. Join.unwrap. So I guess that will actually give us the result if we return something. So let's try and print it. Thread has completed, and we'll say result, and we'll see if that's actually what it gives us. Wait, print placeholders. What is it complaining about? Result.unwrap cannot be formatted. Okay, what is the debug format? I think that's it. No, colon question mark, that's what it is. Colon question mark. Okay, there we go. So now let's try in our thread to return something. Return thread return value. Awesome. Okay. So, we've got a really nice example. Almost done with it, but this is going to kick off a thread, return a value from the thread, and it's going to let us wait until the thread's done and get a value from it. But what I'd like to do is get a value. I'd like to share memory between them. And so it sounds like a channel is the way to do that. So what I'm going to do is leave this example as it is. And I'm going to create a new one called channels. oops, cargo new channels. So I'm going to leave the multi-thread one alone. Actually, let's see, go back to the README. So we've got the multi-threading, channels, and I was curious about thread pools. I wonder if they have a built-in... Okay, so multi-threading is a done one now. And again, if anybody just tuned in, these are some of the examples that we've completed. And today we looked at cross-compiling. I did Linux to Windows cross-compiling. We looked at wrapping C libraries and linking to custom C libraries in a custom location. Just did multi-threading. And now we're looking at channels and thread pools. Channels being the way that you communicate data between threads. And thread pools, you can create your own thread pools just by tracking how many threads you have active. But I'm curious if they have something like Python does, where they have a data struct called a thread pool executor, and you can just tell it, hey, I want you to have 32 threads, and I want you to execute all of these as soon as you can. So we'll see if it has that. But first, let's do channels. And so I'm going to open up this channels project that we just created. Tell it to use my channels project cargo toml file. And it's probably just further down in this page. Using move closures. I'm not familiar with those. What are those? The move closure is often used alongside thread spawn, because it allows you to use data from one thread in another thread. So is this different than channels? It sounds kind of like what I was looking to do. In chapter 13, we mentioned we can use the move keyword before the parameter list of a closure to force the closure to take ownership of the values it uses in the environment. This technique is especially useful when creating new threads in order to transfer ownership of values from one thread to another. So that kind of sounds like a lock or a mutex, where it's basically saying move ownership of the lock for that variable to another place, to ensure that only one person's ever modifying it at a time. I say person, one thread is ever modifying it at a time. So in 16.1 closure, we pass thread spawn takes no arguments. Yeah, that's fine. Oh, yeah. To use data from the main thread, the spawn thread's closure must capture the values it needs. In listing 6.3 below, shows an attempt to create a vector in the main thread and use it in the spawn thread. However, this won't work yet, as you'll see in a moment. Okay, so it looks like they're just trying to directly reference a variable inside the thread, and that won't work. You have to pass it, and they're saying use the move to do it. So let's see. The closure uses v, so it will capture v and make it part of the closure's environment. Because thread spawn runs this closure in a new thread, we should be able to access v inside that new thread. But when we compile, we get the error that says you must force the closure to take ownership of v. Okay, so that prevents you from having multiple people touching it. Rust infers how to capture v, and because println only needs a reference to v, the closure tries to borrow v. However, there's a problem. Rust can't tell how long the spawn thread will run, so it doesn't know if the reference v will always be valid. Okay, so the next one provides a scenario that's more likely to have a reference to v that won't be valid. Okay, so that's an example of how it might break and why they enforce it. And I just want to go down. Oh, you just throw the keyword move in front of it? That's all you do? And it'll automatically capture everything? That's interesting. Using the move keyword to force a closure to take ownership of the values it uses. So if you just toss move in front of your closure, it'll just automatically put a lock on every variable that it uses until it's done. At least that's what it sounds like they're saying. And that's interesting. That's a pretty straightforward way to put a lock on a piece of data. Oh, no, are they giving me more examples that don't work? What would happen in 16.4? Oh, no, that was the broken example. Okay. So that's cool. Messages is really what I was looking for. It's nice to know that little move thing. I'll kind of file that away in my brain, but I'm not going to do a code example on that. Using message passing to transfer. This is what I wanted. I wanted channels to pass messages. One increasingly popular approach to ensuring safe concurrency is message passing. They even reference Go specifically, where threads or actors communicate by sending each other messages containing data. Here is the idea in a slogan from the Go documentation. Do not communicate by sharing memory. Instead, share memory by communicating. One major tool Rust has for accomplishing message sending is a channel, just like Go. Cool. A programming concept that Rust's standard library provides an implementation of. You can imagine a channel being like a channel of water. Yeah, no, I understand channels. Message passing sync channel? Is that what MPSC stands for? I don't know. Okay. A channel in programming has two halves, a transmitter, receiver. Here we'll work up a program that has one thread to generate values and send them down a channel, and another thread that will receive the values and print them out. Okay, so yeah, let's try making a channel. We'll call it let my channel equals I guess you're not creating a channel, you're creating two. We'll call it transmit and receive equal, what is it, NPSC channel. Okay, and we need to alt enter to import. And then now that we have these, I guess we can say transmit.send. And I don't know, can we send anything? And receive.receive. Is it really that easy? And I guess you could probably do it outside of it. Well, I mean, technically we're in a thread, we're in the main thread. So I guess this is probably the simplest use case, and then all you'd have to do is like put this in a thread and put the other one in another thread, and you're just basically guaranteed to have some nice thread safeness. So I wonder, can I just right click and run? Could not compile channels. Oh, I need to fix my print line statement. And I'll do the debug output. And I will run it again. And it worked. Oh, this must be one of those options or something. So let me do receive.unwrap. Is that what you do? Yeah, receive.unwrap. Okay, so there we go. Boom. And so I guess can we send any kind of data? And what if we do two things in a row of different types? Oh. No, so it expects them both up here to be strings. Can I do something like this and tell it to do ints? No, maybe... Well, let's see. Maybe does it have to do with the fact that... Yeah, okay, that's cool. So it doesn't care what type you put into it when you start, but as soon as you put a type into it, then it becomes bound to that type. It's either that or it's like the compiler inferring it. So, well, either way, that's what's happening. So Like if I just do a number this time and I run it, I guess it's going to print out the number just as well. Okay, so you got to stick to one type, but you can just as easily do whatever you want. What happens if I send 2 things before doing a receive? Okay, do I have to do 2 receives then? And if I do 2 receives in a row, I'll get both of the values in the same order they were received. Any type can be passed. And that's cool, you can even pass your own complicated data structures. Awesome. So that's a decent enough example of channels for me. I mean, I could... Well, let's see how they pass in the channel. Yeah, so they just use move, and I guess they only pass it either the send or the receive. Okay, that's pretty cool. So let's do, let's comment that out, and then let's make a thread. So we'll do thread spawn, and we'll say move, and we'll make a note that adding move puts a lock on all variables in the thread. Okay, move, and then we're going to give it a closure with a block of data. Import spawn, and then we want to say, we'll do a print line. We'll say sending data into channel. And we will do, what do we want? We want transmit.send, and we'll actually put these 2 lines in there. Okay, so we'll send from that thread, and then we can say let sending thread equal that, and then we'll say sending thread dot join, and we'll just wait. And I guess they want us to call unwrap because you must use it. And then so we'll just wait to make sure that they get sent, and then we'll just make sure that we've got receiving thread equals thread spawn, and we'll do the same thing. We'll move to ensure that we get our receive.receive, and then we unwrap whatever we receive, and we'll print it out. So we'll say receiving data dot 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 print line debug output, and we want to do it twice since we sent 2 pieces of data, and then we'll do the same thing. Receiving thread dot join dot unwrap. Okay, so if we run that, it should work. And let's see, maybe add just like a sleep, just to give it some kind of duration dot from sex1. I think that'll do it. Okay, now I'm going to rerun it. Compilation error. Time.sleep. How did I do it in the other one? Multithreading, source, main. It is thread sleep time. Oh, it's also colon. Okay, there we go. Okay, so we'll see sending data, receive data, boom. Now, how do we wait? How do we wait on a channel? Now, okay, let's do this then. Let's not block the sending thread, but let's have it wait. We'll say thread sleep, let's just copy this. Thread sleep for 2 seconds. And then let this one run, and we'll wait for this one to finish. So hopefully this one will wait, and sit there and wait until it receives the data. So we'll see if it's blocking by default or non-blocking by default. Receiving data, it's waiting, boom, and after it gets it, and in fact, let's just add a sleep between each one, just to kind of be extra sure. Boom, 2 seconds, boom. Okay, blocking by default. Cool, so you can use that to get a signal, so like, wait till a thread's done, wait for a response, process results as they come in, and you can probably just wrap that in a loop, and just like loop over the results and process results as they come in. Channels and ownership transference. Okay, so this is a good example. This is really helpful. Let's say waiting for data, waiting to receive data. Okay, I'm going to save that example. Let's see, git status. So we've got git diff. What's going on in there? What changed? Oh. Okay, so let's go ahead and add our multi-threading and our channels examples. And we'll say adding multi-threading and channel examples. And we'll say adding Rust. Git push. Git push, yeah, we'll set the upstream to master. Okay. Okay, so we did multi-threading, we did channels. We did channels and ownership. Okay. Ownership rules play a vital role. So move, we looked at what that does. Attempting to use val after we've sent it down the channel. Oh, okay, so interesting. After you pass something down the channel, what happens to it? Are you just passing the reference? Yeah, so here we try to print the value after we've sent it down the channel. Allowing this would be a bad idea. Once the value has been sent to another thread, that thread could modify it or delete it. So we shouldn't be allowed to use it once we send it through the channel. Okay, that makes sense. Our concurrency mistake has caused a compiler error. Okay. So what does it say? This stops us from accidentally using the value again, sending it. The ownerships. So I guess if you want it back, you'll have to receive it back through a channel the same way. Okay, well, I really do like that. I really like the way that it enforces the ownership. And I think that is one of those big benefits that everybody's always claiming for Rust. And I can see now why. So that makes sense. I like that. Now, one thing I want to add here is packing binary structs. I'm curious how you deal with binary data. Like if I wanted to make a raw packet structure for sending out packet injection, how easy can I just make like, okay, I want an 8-byte of this, an 8-byte of that, a 16-byte of that, 16 bits rather, and craft a packet structure and then convert it to raw binary. Well, I guess technically it's raw binary in the memory, so I just want to create that struct in memory. Okay, so we just saw how sending a value through a channel also sends off the ownership. Like when you send it through the channel, you are sending it off in the mail. It's no longer yours. Okay. Sending multiple values and seeing the receiver waiting. Oh. So you can tell whether the sender or the receiver is waiting or not? Okay. So in the main thread, we're not calling the receive function explicitly anymore. Instead, we're treating Rx as an iterator. Okay. For each value received, we're printing it, so they're just saying for... Now, wait a second. Here we go. For received in Rx. Oh, that's really cool. So I guess by default, it'll just sit there and block and wait. So, like, okay, that's a really handy built-in feature. I really like that. Because we don't have any code that pauses or delays in the for loop. Anyway. Creating multiple producers by cloning the transmitter. Oh. So let's say we had 8 threads that were all going to send data into one processor thread. MPSC is an acronym for Multiple Producer, Single Consumer. Oh, okay, that's what it stands for. Let's put Multiple Producer, Single Consumer to use by creating multiple producers that are sending to a single receiver. Okay, so you just actually call something called clone. So you get the transmit channel, and you basically just say, oh, you need another one? Just clone it. Just clone it, and you'll get another one. Okay, easy enough. I'm not going to do code examples for that, but it's good to know. Shared state concurrency. Okay, let's see. So we're almost done through the whole concurrency chapter, and we got some good examples. Message passing is a fine way of handling concurrency, but it's not the only one. Consider the part of the slogan from the Go language. Communicate by sharing memory. Now, what would that look like? Well, to me, that means you're sharing a pointer. You're giving all the threads a pointer, and you're saying, hey, all of you can operate on that block of memory, but that's like 4 people with a pencil trying to write on the same piece of paper. It can get messy. They can overwrite each other. In addition, why would message passing enthusiasts not use it and do the opposite instead? Well, we already know that. I already understand that. So using mutexes. Okay, so mutexes. So same thing with Go. Like they prefer channels, but if you really want a mutex, you can use one. And I've never had to use a mutex over channels, so I'm not going to do an example for it. But it is good to know that they have it, and it looks like it's real easy to use. Looks like it's real easy. Okay, so next piece, the last piece of the concurrency is extensible concurrency with sync and send traits. How important is this? How cool is this? The sync marker trait indicates that it is safe for type implementing sync. I'll skip over this. Maybe I'll go back to the top and read it. Interestingly, the Rust language has very few concurrency features. Almost every concurrency feature we've talked about so far in this chapter has been part of the standard library, not the language. Your options for handling concurrency are not limited to the language or the standard library. You can write your own concurrency features. 2 concurrency concepts are embedded in the language: sync and send. Okay, yeah, I'll skip over that. I got really what I needed. The multi-threading and the channels, that's really all I'll ever use, I'm pretty sure. So yeah, actually thread pools. I wanted to see Rust thread pools. Do they have thread pools? And I'll get rid of that. Oh, it looks like it's a third-party library? So yeah, it looks like you have to implement it yourself, or use a library that someone else has implemented. And implementing a thread pool is not hard. All you have to do is keep track of the count, and whenever one finishes, you decrement it. And with the channels, it makes it really easy. You would just clone. What you would do is you would create the transmit and the receive. You would save the receive And basically you'd have a loop that said for message received in the receiver, decrement the number of active threads. And then you would take the transmit one and you would clone it and send it into every thread, and you'd move it into the thread. And then in each thread, when it's done, right before it returns, you would say send a done message, send a message that I'm done. I guess that, or you could probably store the when you spawn a thread, you could spawn a thread and then save the handle. You could save the handle in a big list, and then you could go through it and I don't know, just loop over that and see which ones are still running. Just thinking out loud here, but that's how I've done it before. Now wait, this is yeah, let's see. Wait, did they have a class called threadpool? This is the official docs. Oh no. So actually what they're doing in the one before is designing a threadpool interface. Okay, so they're actually creating the threadpool. Yeah, so it's definitely not like a built into the language. That's fine. I just wanted to see. So, let's see. Packing binary structs. Let's see. Rust creating structs. Defining structs. Oh, okay. Chapter 5. Defining structs. So actually what I want to look up is Rust data types. I think that's really what I want. Okay, yeah. So you can very easily get the integer size you want here. I8, I16, I32, and U8, U16, U32, U64, floats, float 32, float 64, array, slice. Okay. Okay, cool. That's really what I wanted to look at there. So you can create a struct and you can be pretty explicit about it. No problem. Actually, I'm going to leave it on the to-do because maybe in the next one I will want to do this, and I'm going to say create a TCP IP packet struct. Okay. How to share a library. Okay, I think that's all I'm going to cover for today. Unless there's anybody in chat who may have a request or something. Is there anything that anybody in chat wants to see in Rust, or maybe any questions that I can look up real quick? But I'll recap right now before we wrap it up. So this is my second sit down with Rust. In the first one, I made it through learning the very, very basics like Hello World and how to utilize some libraries. Today we did all of these. So we looked at how to cross-compile. We cross-compiled from Linux to Windows. We looked at wrapping C libraries that are in our system. We looked at linking to custom C libraries that are built in custom locations. We looked at multithreading and channels and ownership. And I think that was really good. You know, the one that I think took the most time was linking to custom C libraries and figuring out how you have to build custom build scripts to output custom configs to tell it where to find your custom libraries. But let me see here. I think we got some more changes. No. Okay, so if you are interested in any of this code, go to github.com/devdungeon/cookbook. Scroll down to the Rust. And this has all the examples that we've been working on. So leave comments for anything that you want to see. Anything that you may be interested in next time. I still have some unfinished topics, so I'll probably sit down for another cookbook session and look into some of these topics. So I'm gonna wrap up by pushing my changes and pushing it. And I'm gonna say thank you to everybody for coming out tonight, everybody who chatted. And let's see, if you haven't already joined the Discord server, you can go to devdungeon.com, and there's a big Join Me on Discord button on the right sidebar. Click that and come join us on Discord. Check out my book, Security with Go. Check out the Dev Dungeon YouTube channel, where I try and stream every night, starting about a couple weeks ago, and it's been pretty consistent. So I cover everything from Python and Django to writing Ruby backup scripts. The other day we covered exploiting Drupal in one of the new CVEs that came out. And I do some Minecraft stuff. I run a Minecraft server and I do a lot of live coding on the plugins here. So if you like Minecraft, come join minecraft.devdungeon.com and play. Otherwise, subscribe and tune in tomorrow. I hope you all have a good night.